Right, okay, so a video on microcontrollers, maybe slightly differently to the other questions going through the other videos going through some of the questions. I've just picked out some main points with it. So first of all, we need to be able to either turn things off and on, and also be able to configure the ports so that they can turn things off and on. So the first thing that we're told on this question here is we've got a heater connected to bit 7. Bit 7 is the most significant bit on port A, and we want to turn it on. So bit 7, then we're going to have a 1 there, and then 1, 2, 3, 1, 2, 3, 4. Okay, so that's what we end up with. There's not a lot of space there to write in on there. So bit 7, we want to make a 1 because we want to then to turn it on. And then what do we do with that value that's in the working register? Well, we need to take the value in the working register and put it in port A's file register. So looking on the instruction sheet, we need to use the mov command and move from the working to a file register. Which file register? Well, it is port A's file register, making sure that we write in capitals there. In configuring port A so that it does what it does, we're told that we want the 3 least significant bits to be inputs. Inputs are, we put a 1 into the register. They would be classed as a 1. So what are we going to put in first? Well, the binary pattern then we're going to put into the working register then is whichever way you want to start from. We're going to have 4 zeros there, and we're going to have a 0 there, and we're going to have 3 1s there, like so, so that the 3 least significant bits in port A are 1s. 1 are inputs. 1, it looks like an I, doesn't it, for inputs, and a 0 means output. Okay, and where do we need to move that? Well, we need to move that from the working register to file register. Well, it is tris A is the file register that handles port A. Okay, so tris A is used to then define on port A what bits are used as inputs and outputs. Right. The next thing we want to then look at is how do we handle interrupts. So there's certain bits on interrupts that we need to make sure that that we configure correctly. Okay, sorry, here we go. So how do we turn interrupts on? So we've got the interrupt control register that does this. So first of all, to turn interrupts on, we need to make sure that there is a 1 in bit 7. Now bit 7 is the general interrupt enable. So we need a 1 on there, and we need to then turn on bit 4, which is the turning on external interrupts. Okay, and then so that interrupts can happen, we then want to make sure that we put a 0 there for the interrupt enable flag, and when an interrupt occurs, that flag, this bit 1, will then go to a 1, and that's how the microcontroller can tell that it needs to carry out an interrupt. And it's also how we can also check that if we wanted to in our code whether an interrupt has occurred or whether we've accidentally got to the interrupt code. So these two need to be 1 so that we can turn on interrupts, and this is our interrupt flag that we need to make 0. Now that's what we do it in the register. Now you can obviously then output that, then put that into the working register, then output it to the intcon register, or you can do it by setting these 2 bits and then clearing that bit again in the intcon register. So let's have a look at a further question. So this is obviously now building upon our knowledge. So we need to then turn on bits 1 and 3, on port A for 3 seconds. Okay, so how do we do that? Well, we need to move a value into the working register. And what are we going to put into the working register? Well, we need to have bit 1, bit 3, and everything else is going to be zeros. Yeah, Mr. 0, there we go. So that, bit 0, bit 1, bit 2, bit 3. So bit 1 and 3 are 1 because we want to turn them on. So then that gets moved into port A. Okay, that moves into port A, and then we need to conduct a for 3 seconds. Well, in this case, there's a 3-second subroutine that we can use. So we're going to call that. So we use the command call for subroutines, and it's called 3sec. Then what do we need to do? The LED is connected. They then turn off, and the LEDs connected to bits 0, 2, and 4 on port A light up. Okay, so we're going to move into the working register, and we need bits connected to bit 0, 2, 4, okay, so let's just check that. Have we got bits on bit 0, 2, 4 illuminated? Yes, well, they're all 1, which is obviously the same as that instruction there. Okay, so we're going to move that onto port A, call the subroutine for 3 seconds. Right, okay. So we've done those lines there. So what does the interrupt service register, what is contained in the interrupt service after the interrupt service routine is completed and the processor returns to the main program? Okay, so if we look at our program here, we're taking what's in the working register and we're storing that into the file register store, and then we're then putting what's in the back into the file register. So therefore, what's in there is what we're left with, which is going to be 1, 2, 3, 4, 1, 0, 1, 0. Okay. And then we say during the execution of the server stream, what does after the processor executed line 207? So line 207. So we've just taken what was in the working register and put it out on port A. Well, what was in the working register is that value there. So that's what we have there, like so. Okay, right, one last little thing then on as a quick recap on then microcontrollers. If we wanted to connect up so that we could carry out an interrupt service routine, then we need to connect up our IC as so. So first of all, we need to connect the power to the IC. So if we look down like on our chip here, pin 14, that's pin 18 here. This one here is VDD, and it needs to go to our 5 volts. The opposite side of that needs to then go down to 0 volts, okay? And RBO0 is this one here, which is our interrupt. That's what we then need to connect to for our interrupts to occur. Now, it can be configured, so in this case, falling edge triggered on RBO0. So on a falling edge triggered, that means that the signal then is going low, so it must be being kept high to start with. So therefore, in this case, then I'm going to put a switch and a resistor in like so, so that when the switch press, we get a falling edge triggered signal on the interrupt. But you just need to read the write-up to see whether it's a high going or a low going signal onto your interrupt pin. Okay, and that is a very quick blast through on microcontrollers.